Imagine looking up at the night sky before we had any real answers. You've got these beautiful stars, but some of them, well, they wander. They move in these weird, unpredictable ways that, for centuries, just baffled everyone. But then came Johannes Kepler. He was convinced that all that chaos wasn't chaos at all. He believed there was a secret pattern, a kind of divine harmony, all written in the language of math. And, well, his journey to find it, it completely changed how we see the universe.
So, that's the big question, right? How did we finally find some order in all those wandering stars? For literally thousands of years, everybody just assumed the planets moved in perfect circles. It felt divine, you know? But the problem was, when you actually watched them, it just didn't add up. The observations never quite fit. So how did we leap from this big cosmic mystery to actual predictable laws? Well, it all comes down to this one brilliant guy, a mathematician whose faith was so strong he was sure the data itself was a message from God.
Okay, so this was Kepler's first big idea, or at least what he thought was his big idea. In 1596, he comes out with his book, the Mysterium Cosmographicum, and inside is this absolutely stunning, intricate model. He truly believed he had cracked the code, that he'd found God's secret blueprint for the entire universe. His theory, that the orbits of the 6 planets we knew about back then were perfectly nested between the 5 platonic solids. You know, those perfect 3D shapes like a cube or a pyramid. It was beautiful, it was elegant, and as we'll see, it was wrong.
Right, so to really get where this idea came from, you have to get Kepler and the world he lived in. This wasn't just some mechanical puzzle for him. No, he was on a much bigger quest. He was searching for a divine harmony.
So, Kepler was born back in 1571, right in the middle of the Holy Roman Empire, a time just buzzing with new Renaissance ideas. He started out as a brilliant math teacher, but he was obsessed with these huge questions. Why are there only 6 planets, and why are they spaced out the way they are? For him, these weren't just, scientific puzzles. Answering them was like reading the mind of God, figuring out the very blueprint of creation itself.
And you've got to understand, his ideas didn't just pop out of thin air. The culture he was living in was completely fascinated with complex geometry. I mean, look at this stuff. Artists were making these incredible wood inlays and publishing books filled with these wild polyhedral shapes. The very same shapes Kepler was trying to fit into the solar system were a full-blown artistic obsession at the time.
And this quote from Kepler himself really gets to the heart of it all. He says, "I wanted to be a theologian, but behold, God is now also glorified through my work in astronomy." I mean, wow. For him, there was zero conflict between science and faith. He saw his work in astronomy as a form of worship, a sacred duty. He was basically reading the book of nature to praise God's creation.
So Kepler had this incredible, beautiful theory. But a theory is just a theory. To prove it, he needed one thing he just didn't have: cold, hard, precise data. But that was about to change thanks to a partnership that would give him the keys to the cosmos.
He lands a job as an assistant to the one and only Tycho Brahe. Now, Tycho was a legend. He was the greatest observational astronomer of the era. This guy had spent decades just meticulously, night after night, plotting the exact positions of the planets with accuracy nobody had ever seen before. So you have this perfect pairing: Tycho, the master observer with all the data, and Kepler, the brilliant theorist with all the ideas.
And then, in a twist of fate, Tycho dies suddenly in 1601, and guess who inherits his entire life's work? Kepler. Just like that, he's sitting on a treasure trove, the most accurate, most comprehensive astronomical data that existed anywhere in the world. This was it. This was the raw material he needed to finally test his beautiful geometric theory against reality.
Okay, and this is where the real drama begins. Kepler's got the data, he's ready to prove his amazing Platonic solids model once and for all, but the universe had a surprise for him.
This conflict almost broke him. Seriously, he spent years trying to make the orbit of Mars fit a perfect circle. A circle was, divine, perfect. It had to be a circle. But Tycho's data was just relentless. It wouldn't budge. The numbers simply did not lie. Mars was off, not by a lot, just a tiny little bit, but it was an undeniable difference. And this is a huge moment in science. For maybe the first time ever, a scientist had to throw away a beautiful, cherished theory simply because the facts didn't support it.
So after all that grueling work, all those calculations, he finally gave in and just followed the data, and it led him to the truth. And what a truth it was. Law number 1, planets don't move in circles at all, they move in ellipses. Law number 2, they actually speed up when they get closer to the sun and slow down when they're farther away. And law number 3, there's this perfect, beautiful mathematical relationship between how long a planet's year is and how far it is from the sun. Just like that, the chaos of the wandering stars finally made sense.
But Kepler wasn't done. Oh no! His quest to figure out the heavens actually led him to completely change how we even look at them.
So in 1610, Kepler hears about what Galileo is doing with his new telescope, and he's completely fascinated. But he doesn't just want to see what Galileo saw. He wants to know how it works. How does this thing actually let you see farther? So he dives in, and the result is this book, Dioptrice. And it is literally the first real scientific theory of how optics and lenses work.
He basically invented a whole new field of science right there, dioptrics. He's the one who figured out the math of how lenses bend light to a focal point. And this wasn't just about explaining Galileo's toy, it was the theory that allowed us to build bigger, better, and way more powerful telescopes for centuries to come. He laid the groundwork for everything that came next.
And you know what's amazing? Through all of this, proving himself wrong, inventing new fields of science, his core motivation never changed. Yeah, his beautiful model with the nested shapes was a bust. But his fundamental belief? That was stronger than ever. He saw that the universe wasn't just some random machine. It was a rational, divinely ordered place. And by figuring out its mathematical laws, he felt like he was getting a peek into the mind of God, the grand geometer.
So, when you boil it all down, what's Kepler's real legacy? It's not just that he helped us understand the universe, it's that he made it predictable. He gave it a rhythm.
In 1619, he publishes his amazing third law in a book called The Harmony of the World. Fast forward a few decades, and a young guy named Isaac Newton starts reading Kepler's laws. But Newton asked a different question, not just how the planets move, but why they move that way. And the answer to that question was his universal law of gravitation. You see, Kepler gave us the how, and that became the absolute foundation for Newton to figure out the why.
It's funny when you think about it. Kepler started his whole journey looking for this rigid, perfect geometric structure in the sky. But what he found was so much more beautiful, so much more profound. He found a dynamic, harmonious symphony, a cosmic dance where every planet moved according to these elegant, unbreakable mathematical rules. He turned those chaotic, wandering stars into a predictable rhythm. He didn't just look at the stars, he gave them a beat.